I'd like to introduce you to Nicolas Serandour, the CEO of Advanced Oncotherapy, who are currently developing an amazing breakthrough in the exciting world of proton therapy and the treatment of cancer. So, Nicolas, I'd like to ask you, what is the difference between radiation therapy and proton therapy?
Radiation therapy is one of the three major modalities to treat cancer. It uses photons to damage the DNA of cancer cells, and the principles are well known, with more than 13,000 X-ray machines in the world treating somewhere between half to two-thirds of the cancer cases. Unfortunately, X-ray also damage the healthy tissue surrounding the tumor along the path. This limits the ability of physicians to kill the tumor, and it seriously impacts the quality of life of patients. With proton therapy, we're using a charged particle called proton. Protons damage the DNA of cancer cells exactly the same way as X-ray, but they only deposit most of their radiations where protons stop. That means up to 60% of healthy surrounding tissue is being spared from radiation.
And from what I believe, this 50-year-old technology is only present in 68 centres around the whole world. Why is this?
In proton therapy, the level of energy tells you exactly where protons stop. So if you need to treat a superficial tumor, you need a low energy. With the machines which are available today, the designs are circular. So protons get accelerated in a circular manner, and protons at the end of the accelerators come out at the same and full energy. That means if you have to treat a superficial tumor, you have to put absorbers at the end of the accelerator, which, as the name suggests, absorb the energy. But that process is highly inefficient, creating significant unwanted radiation. This is why site needs huge shielding. The sizes are very large, sometimes as large as a football pitch for legacy systems. They are costly to build, to install, maintain, decommission the machines. And that cost gets passed through to the patients, with treatment costs sometimes in excess of £100,000 per course. This is the fundamental issue of proton therapy.
So what exactly is needed?
The market needs smaller and cheaper machines. But this is not possible with a circular design. At AVO and a subsidiary ADAM, we have developed a linear accelerator, whereby protons get accelerated as they go through the machine. Once they reach the right level of energy, the acceleration is then stopped, which means we don't need absorbers, and then suddenly all the technical and financial constraints go away.
Okay, so I take it this is why you're planning to install the machine in Harley Street?
Absolutely. This site consists of two listed adjacent buildings in the heart of London. This is extraordinary to be able to put a proton therapy system in such a dense area. With a customer Circle Health and the landlord Howard Walden, who are bearing for the building costs, we aim at treating first patients toward the end of 2020. This will be a first site before we can install many more machines around the world.
Am I right in thinking that the linear accelerator is a lot more beneficial to patients than the circular accelerator?
The design of a linear accelerator means we can change the energy very rapidly in an electronical manner. In contrast, circular accelerators can have the energy being changed in a mechanical manner, which is much more slowly. Therefore, a linear design allows to much better target particularly tumors which are moving, such as a lung cancer.
Okay, so how are you planning to prepare for the demand in the future?
The design of a light machine has been developed for more than 25 years at CERN and a subsidiary ADAM. This design is novel, it's unique, and it's patented. A lot of work has been done on the quality of the beam. We are working with world-class partners such as Toshiba, Thales, or VDL, to name a few. Importantly, the design of the machine is modular. That means for the first time, we can mass produce machines, meaning the lead times for manufacturing is much shorter, the cost is much lower, and importantly, the installation is much easier. This is a very key differentiating factor in the industry.
Okay, and last of all, what's the bottom line?
We have built all the foundations to deliver a sustainable, fast-growing, and profitable financial case. I know I can count on the commitment and dedication of a very experienced team who sees this project as a great opportunity to do good and well. With this project, proton therapy can be delivered to many, in fact, to most patients, as opposed to only a minority of patients who can afford it. Proton therapy is going to become the reality for every cancer patient.
Nicolas, it sounds like a fascinating project. Thank you so much for speaking to us today, and we'll be looking out for any further updates in the future. Thank you.
Thank you.